In this video, we'll discuss about the linear sequences, that what does it mean by a linear sequence, how do we solve the different type of problems related to the linear sequences, and why are the linear sequences useful. Well, I have a clear example for you. Just have a look at this picture, and for example, this is the structure of a building. In this structure, in the first floor, for example, there are three apartments or three offices. In the second floor, again, there are three offices in the same way at the same places. Similarly, in the third floor, in the same way, same places, there are three apartments or three offices. For example, if the building is 18 floors tall, and you want to check, you want to find how many offices will be there in the whole building. So of course you can clearly see, because in the first floor there was three, then there were three more, then there were three more, so three more, it goes in that way. And you have to check in the 18th floor, if the building is 18th floor tall, in the 18th floor how many offices will be there. Or going a little deep in this, let's say if you say each office of the building or each floor of the building requires let's say 12 doors. This also needs 12 doors for all of the offices, 12 doors. And then you want to check, when you're constructing or when you're developing this, and you want to check how many total doors will be required to fill up the building, or to completely construct the building. So you will just calculate in that way. You will just check 12 doors are required for the first floor, then again 12 more, so it will be 24 for 2, and 36 doors for 3 floors. And if the pattern goes on, and you want to check until the 18th floor, so how many total doors will be required. So in these kind of things, you can clearly see that everywhere we have followed the same rule. So for example, in this one, when you counted the offices, we just counted there were 3 rooms there were 3 offices, there are 3 offices, so we just counted the same rule. We just counted 3 more every time. So the gap between the numbers, or the gap between the total things, were just 3 in each of the thing. Similarly, when you talked about the doors required, we checked 12 doors were required for the first floor, then 12 more, then 12 more. So the pattern or the rule was, you just had to count 12 more each time. So this particular rule, whenever the rule between the terms, between the numbers, between the gap between the terms is same, this rule is called the linear sequence. This is a sequence. You can clearly see they are going in the same pattern, in the same way. So this is the sequence of the numbers of the things. And then since the sequence of the thing is going following a same pattern, following a same rule, so this is called the linear sequence. We have some more examples over there. We have clearly the 4 times table, the 7 times table. What's the common between these times tables? You can clearly see that it is just adding 4 in each of the numbers, and then adding 7 in each of the numbers. So the pattern for this one will be adding 4 everywhere and adding 7. So these are also the part or the examples of linear sequences. The next is, how do we solve? For example, if we have this 4 times table and we want to check what will be the value in this pattern, if the pattern goes on, which number or which value will be the 80th value, in the pattern, when will 80 come? So of course it's not easy, or it's not intellectual that you just count 4 every time. So for example, you're 20, then you count 24, 4 more, then you count 4 more. So that's of course not easy and not a smart thing to do. So there should be a short way, and there is a short way. That short way is called the nth term, or just representing the whole scenario, the whole pattern in a general way. That general way is called the nth term. So we'll just move to that. All right, so let's evaluate, or let's work out how do we find that nth term or that general term for all these things. I'll just write it's the nth term. Basically, if you recall algebra, whenever you see something that's not a number, that's an alphabet, that's a letter, so it actually represents something or the number of values. So this thing. Similarly, nth means if we have to find the 10th, that 10 will represent the n. If we want to find the 17th, that 17 will represent n. So n is basically a number represents anything that you require. Anyway, we have to check what is the short way or what is the nth term to find the pattern. The short way is that if you clearly check that this is in the sequence of 4 times table, you can see clearly the gap of each term or each number is adding 4 all the time. So it means it will be 4 times n or 4 times any number. For example, if you want to find the second number, you can do 4 times the second number and that will be 8. So it's the way. The gap is adding 4, so it will be 4 times n. So you have to check in this thing, 4 is already there. So in this thing, what you have to add to get the very first number? So in 4, what you have to add to get 4? You don't have to add anything or just 0. So it means that is the representation of this whole thing. Move on to this. We have this pattern over there. So you can clearly see that the gap between each term is adding 7. So it means the nth term for this will be 7n. And now you have to check in 7 what you have to add to get the very first term, to get the very first number. So since this is 7, you already have 7 there, so you don't really have to add anything. So it will be just 7n plus 0 or just 7n. And if you want to check, you can check. This was just 4n plus 0 means nothing, so it's just 4n. And if you check, if you replace, since I told you n represents the number or the number of value. For example, if you want to check what was the third value, so just change n with 3 because n represents the number or the value. So if you want to check what was the third value, so change your n with the third 3, and 4 times n means 4 times 3, and that will be 12. So it means you are correct. So this represents this pattern. Same is there if you want to check what was the fourth value. So fourth value means you have to change your n with 4. So 7 times n or 7 times 4 means 28. And you can see 1, 2, 3, fourth value is also 28. So you are correct. So this is the way, just to pack everything into the algebraic format. If you move further, this time you can see this is not a particular timetable, but there is a rule. The rule is, you can see from 2 to 5 you can add 3 in it. From 5 to 8 you can also add 3. From 8 to 11 you can add 3. 11 to 14. So this time the rule is adding 3 every time. So it means what will be the general rule, what will be the nth term? So since it's adding 3, so it will be 3 times n. Again, now you have to check in this number 3 what you have to add to get the first number. So since 3 is more than 2, it means you don't have to add. Basically you have to add backwards, or you have to minus. So you have to take away how much? You have to take away 1, because 3 take away 1 will give you 2. So it means the rule for this, if you apply the operations of integers, so positive times negative actually means negative. So this thing will be, in short, 3n minus 1. Now check if you wanna verify that your fifth answer, since 1, 2, 3, 4, fifth answer is 14. So just change n with fifth, n with 5. So it will be 3 times 5 minus 1, and you can see 3 times 5 is 15, and 15 minus 1 will be 14. So you are correct.